All right, we're looking at PACE 1134 again, page 39 this time. And instead of coterminal angles, we're going to look at what are called theta prime angles. So remember that the quadrants are numbered starting with this one being quadrant 1, and then it goes to quadrant 2, quadrant 3, ends up in quadrant 4 down here. All right, so that's the order that we do the quadrants in. Now, theta prime means if I draw an angle that, let's say, comes like this and then up like this, and let's say this is 120 degrees, that's theta. Theta prime would be what angle do we have over here? Okay, that takes us all the way to the axis. So the difference between 180 and 120 would be 60, right? 60 degrees, so that would be theta prime. And then that 60 is what we would use to look it up on that chart over on page 38. Or I think in this case they just want us to write, well, how many degrees or how many radians the answer is in, okay? So they have a formula that we can follow. This one, we notice, it ends up in quadrant 2. So to find theta prime, we follow this formula. 180 minus the angle that's given. If we're doing it in degrees, we subtract, it's 180 minus 120. If we were doing it in radians, then it would be pi. Remember, pi is the same as 180. We can kind of substitute one for the other. If we end up down here in quadrant 3, the formula we're going to use is the angle minus 180. And let's take an example of that. Let's say it's 200 degrees, okay? So 200 degrees would come right here. Boom. So how many degrees would theta prime be? We would do 200, which went past the 180, minus 180, which would be 20 degrees. So theta prime would be 20. Again, if we were doing it with radians, we would subtract pi. And then if we end up over here in quadrant 4, we do 360 or 2 pi and subtract the angle that's given. Let's try a couple of problems here right from your homework. Let's do number 4, 231 degrees. Let's figure out where 231 degrees would be. Well, if I start here and I come up to here, that's 90 degrees. It's 180 degrees. All the way down here is 270 degrees. It's good to know those three marker points. It's 90 times 1, 90 times 2, 90 times 3. So 90, 180, 270. So 231 would be somewhere in here. It doesn't matter exactly where it is. We just need to know it's in quadrant 3. Once you know that, we look up at the chart and we say, aha, I'm going to do 231 minus 180, and then I'll have my answer. I'm not going to finish it for you. You can finish it yourself, but we have it set up now, okay? Let's think about number 5. 5 pi over 4. Well, let's see. Which quadrant would that be in? 2 pi would be a complete circle, which would be 8 pi over 4, right? So 5 pi over 4 would be, so 8 pi would be all the way over here. What would be coming down then? All right, this is my cheat. I gotta cheat a little bit here. This is your, oops, it says my battery's low. Oh well. 5 times 180 divided by 4. I have to, in my head, I have to translate it to degrees. Someday I'm going to get used to doing it in radians, but I still think in degrees. So 225 degrees. So that's still going to be in this same quadrant, maybe right about here, okay? So if we're in the third quadrant, the rule is we're going to subtract pi. So pi would be 4 pi over pi. And so you can see that the answer is going to end up to be 1 pi over, not over pi, what am I saying, over 4. 1 pi over 4. And then we can, well, we don't have to look that up. That's it. We're just trying to figure out what the theta prime angle would be. All right? But you do have to figure out which quadrant it's in so that you know which rule to apply to get the correct answer. All right. Finish page 39, check it, make sure you know what you're doing. And I do see in the score key they have a kind of a solution guide. So if you get one wrong, maybe you'll see a clue there in the score key that'll help you in correcting it.